Okay, welcome back to our channel. So today's topic is already. So today I'll take one example from exponential function again, and then I'll take some polynomial function, and then some example from chemical equation. Okay, so let me take first e to the power minus mod x. Mod x is a very good mathematical function. Mod x is going to give you x when x is going to be in that region 0 to infinity, and this is minus x. Okay, so basically this function is reducing into y is equals to minus x in this region and you already know these two functions in my previous lecture. Okay, so this is going to be very simple for you. At x is equals to 0, y is equals to 1. So this is 1, and this part 0 to infinity, this part is like e to the power minus x, and this part it is like minus infinity to 0, it is like e to the power x. So this is will be like this, and this will be like this. Okay. So let us take one example, e to the power minus x square. So let me tell you one thing, that is if x is going to call even function. You already know, but I have to tell this. Okay, if when f of minus x is equals to fx, and fx is going to call odd when f of minus x is equals to minus of fx, and any even function. Okay, any even function is, if you plot any even function, it is going to be symmetric about your y-axis. Okay, like this or whatever. It is symmetric about y, that is x is equals to 0, and an odd function, it will be symmetric about your x-axis. Okay, so let me draw this. So this function is e to the power minus x square. X, whatever your x is equals to negative or positive, doesn't matter. It will give you always, x square is always positive. Okay, and now as you know, I have to take some value of the function in some point, that is y is equals to 1 at x is equals to 0, at x is equals to infinity. This is going to give you e to the power minus infinity, that is 0. X is equals to minus infinity. This is going to give you e to the power minus infinity again 0. So the function is going to give you value 1 at x is equals to 0 and value 0 in both infinity and minus infinity. So what will be the plot? This is a 0. This will be like this. This will be like this. So you can easily find out that this function is symmetric about y-axis. Okay. So this is about exponential function. Let me take one example from polynomial function. Okay. Y is equals to x square and x cube. I just want to tell. So this is a common practice. You can easily draw the plot by just comparing it with a known curve. Okay, Your known curve is here, y is equals to x. You all know about y is equals to x. This is like, I'm just taking this first coordinate part. This is going to be a straight line, as you know. So y is equals to x. Now what I am telling, that you just can draw this plot by comparing it with your known curve, that is y is equals to x. So if I compare y is equals to x square with y is equals to x, okay, then what will happen? X is equals to x square, that is giving you x square minus x is equals to 0. That is x minus 1 is equals to 0, and x is going to give you 0 and 1. Okay, so y is equals to x square plot will intersect y is equals to x curve at x is equals to 0 and at x is equals to 1. Okay, so this is one information about this plot, y is equals to x square. And another thing, you know that at 0 to 1 in this region, y is equals to x square is always less than y is equals to x. Okay, and in this region x is greater than 1, y x square is always greater than y is equals to x. So in this region, in this 0 to 1, the value will be lesser than this, but at 1 it will be greater than, so like this. Okay, and y is equals to x square is an even function. So it will be symmetric about y-axis. The same part will just be like this. So y is equals to x square plot will be like, this is a parabolic. Okay. Now, if I want to draw x cube, y is equals to x cube. This is a odd function, because if you put x is equals to negative, x is equals to minus x, be specific, then y is equals to minus x cube, and at x is equals to x, that means positive, y is equals to x cube. So this is basically an odd function. So it will be symmetric about x-axis. That is one information. Again, in this region 0 to a, this plot will again be less than y is equals to x square as well as y is equals to x, and in this region x greater than 1, yx cube will be greater than x square and greater than y is equals to x. So if I draw y is equals to x, x square and x cube in one plot, okay, so what will happen? This is my 1, this is x square, and this will be lower, in the up to this it will be lower, but after this it will be greater. Okay, so x square, x cube. Okay, and what I am telling up to this, that is, this is a odd function, so it will be again symmetric about x-axis. And this is quite familiar because at x negative, it will always give you negative value. So this is all about polynomial. So let me come to the most important part. Okay, basically examiners do not ask you simple polynomial function or simple exponential function. They will give you something at the margin of with margin of these two functions, just like y is equals to x e to the power minus x. So this is basically merge of two functions, that is y is equals to x and y is equals to e to the power minus x. And you know these two functions very well. Okay, so now you have to draw a function with this 2 along with this. Okay, so as you know, you just have to take some point and we have to find out the value. X is equals to 0, y is going to be 0 e to the power minus e to the power 0, this is going to be 0. So y is equals to 0 is because of x, and x is equals to infinity. Okay, y is equals to infinity to the power minus infinity to 0. It is 0. So it is giving you 0 because of e to the power minus x. So to draw this, you just have to first draw this 2. Okay, at first draw x and e to the power minus x. This is 1. So in this region, at x is equals to 0, the function is 0. So to get 0, you don't need this part because this part is giving you 1. So just, and at infinity it is again 0. So if you take this part, this is not going to be give you 0. So this part is, so just this. Okay, so your final curve will be like this is y is equals to x e to the power minus x. Okay, so okay, I don't want to take examples mathematically, but I just need to take for example some example from our known chemistry. This is basically our motto. Okay, so you all know about Maxwell speed distribution, that's PCDC. This is going to be m by kt c e to the power minus mc square by 2kt dc. Okay, so if you want to draw a plot between PC versus C, so what happened? Okay, PC versus B. So this part, this is basically a constant. You just need C and e to the power. So this plot is basically like a PC is basically like a constant A C, your function, e to the power minus some constant B C square. Okay, so this is what we discussed. This is like x e to the power minus ax square. You know x, e minus x square, and you know x. So just plot x and e to the power minus x. I already told you this is like this. Okay, this is I'm just taking this part. So this is my e to the power minus x square. This is my x. So in this case, this is actually c, and this is actually minus c square. So what you need to do at you just need to find out the value. At x is equals, that c is equals to 0. This for PC is going to be 0, and at c is infinity, again PC is 0. So you just need to take, okay, to get 0 this part, and again to get this part. So what will be the function actual graph? This will be like so. This is my PC versus C. Okay. So okay, thank you. Keep in touch.